Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on November 6, 2025, about 3 days ago. It proves that randomly initialized multi-head attention blocks and even transformers without normalization already contain strong lottery tickets that can approximate any target attention, needing only a hidden size on the order of d times log of h times d to the 3 halves, and the approximation error falls exponentially as that size grows. The paper is titled, The Strong Lottery Ticket Hypothesis for Multi-Head Attention Mechanisms, and the implications for model training are quite significant. Figure 1 contrasts the classic 2 layers for one idea with an attention-specific strategy that handles query key inner products. The top panel says older proofs prune 2 random layers to mimic one dense layer. The bottom panel show that pruning a randomly initialized attention block with Softmax that turns scores into probabilities can imitate any target attention. The left diagram depicts the pruned source, and the right diagram depicts the arbitrary target it matches. Figure 2 shows how multi-head attention decomposes into per-head computations that add up. The left side illustrates several heads that each form scores, pass them through Softmax, and then produce a value that feeds the output matrix. The right side explains that by partitioning the output matrix into head-specific blocks, the final result equals the sum of each head's contribution. This view matters because the proof selects masks per head that control these blocks, so the pruned network can mimic any target. Well, Figure 3 lays out the proof strategy that turns attention into a matrix approximation problem. The left panel shows the source multi-head attention, where the calculation order changes so query and key projections multiply first. The right panel merges the target projections into 2 matrices, called WQK and WVO, so one matrix stands in for 2. A 2 layers for one approximation, which means pruning 2 random layers to mimic one desired matrix, then selects masks so the pruned product matches the target before Softmax. So the proof strategy came just now. Figure 6 shows how the predictions play out. The approximation error drops fast as hidden dimensions grow, which signals exponential decay. Curves for different block counts sit above one another, so more blocks add error but share the same decay rate. In practical terms, a modest increase in hidden size buys a large reduction in error because each block contributes a small, shrinking term. Alright? Figure 4 shows that the approximation error epsilon drops exponentially as the hidden dimensions for keys and values increase. The blue points come from the subset sum approximation, which means selecting a subset of randomly initialized weights so their sum mimics a desired matrix. The dashed curve fits an exponential, so doubling the hidden size slashes error sharply. This pattern backs the claim that modest over-parameterization yields strong lottery tickets that are highly accurate. 2 takeaways stand out. Strong lottery tickets provably exist inside multi-head attention, needing only a hidden size that grows like d times a logarithm in model dimensions, and the approximation error falls exponentially as that size grows. This extends to transformers without normalization, and suggests a practical nk to the 1/4 power initialization trick. Thanks for listening. I am Alex.